So, question 1. The first part is straightforward. Write down an equation that links kinetic energy, mass and speed. So kinetic energy equals a half times the mass times the velocity squared. Doesn't matter actually if you put speed or velocity in there. Okay, calculating the kinetic energy of the tennis ball. So using half position C, so half mv squared, half times the mass, let's just double check that, 0.058 kilograms. Okay, so that's correct. You can see here the student has just made a small mistake, and the small error is to forget the squared, a very common mistake there. And so we just double check on the mark scheme. So the actual answer should be 0.725 joules. This is a very common question, this next one. At position A, so this is at the top, it's at its maximum height, what is the gravitational potential energy of the tennis ball? Well, they're tricking you, because at the top the gravitational potential energy will be the same as the kinetic energy it had to start with, so you just write in that exact same answer. Another straightforward question, remembering an equation. So gravitational potential energy equals the gravitational field strength. Good idea to write it out in full like this student has, times the mass times the height. And then finally calculate the height of the tennis ball above the tennis player's hands at position B. So we just need a different height there. Oh, there we go. Look, it says has 0.38 joules of gravitational potential energy. So we know that it's 0.38 joules. We know that. It tells us 9.8. We've got the mass of the ball. It's 0.058 kilograms. So it's just a case of rearranging it as the student has done here, putting the numbers in and getting this large value here, 0.66 something. I've given it 3 marks. Probably I should have given it 2 because the rounding is wrong, because obviously 0.67 becomes 0.668 becomes 0.67 meters.